Because in high frequency, we cannot measure voltage or current. So we'll go for a separate family of parameters called as S parameters. S stands for scattering. So scattering, reflection, all becomes dominant at high frequencies. So whatever parameters you measure at high frequencies, they are mostly called by this name called as S parameters or scattering parameters. So this is any two-port network you can see in the diagram. The input voltage is V1, the output voltage is V2, and all the currents are assumed to flow towards the network. So see here, I1 and I2 are flowing towards the network. And I can represent this two-port network by a simple Z parameter equation. V1 equal to Z11 I1 plus Z12 I2. V2 equal to Z21 I1 plus Z22 I2. So this is how you represent a simple two-port network using Z parameter equation, or you call it as impedance parameters. So if I want to find any of the parameter, if I want to find Z11 means I'll make I2 equal to 0. So I2 equal to 0 means I'm making current to be 0. When current is 0, I am open circuiting my terminal. So Z11 will be equal to V1 by I1. If I want to find Z22, I'll make I1 equal to 0. I1 equal to 0 means I am open circuiting my input side. So when you do that, you can find Z22 equal to V2 by I2. So at low frequencies, it is very easy to perform open circuit and short circuit. Then that only if I do that, I can measure the value of the different parameters. So otherwise, I cannot measure them in low frequency condition. So that is what I told here. The same is given here in steps, finding Z11 and Z22. So if you want to find Z11, you have to make I2 equal to 0. If I want to find Z22, I have to make I1 equal to 0. Okay. So similarly, open circuiting the input port and output port, I'll get all these four values of Z11, 22, 12, and 21. So open circuiting we do in Z parameter. The same thing we'll do short circuiting in Y parameter. And when you do the combination of both, it is called as H parameter, or you call it as hybrid parameters. And all these Z parameter, Y parameter, hybrid parameter, ABCD parameter, so all these circuits are very popular in the low frequency because I can find their values by appropriately exciting the circuit with proper inputs and either open circuiting or short circuiting the circuit at necessary ports. But at high frequency, it is not possible to generate this condition for OC and SC because at high frequency, the components are very prone to oscillations. So whenever you terminate with an open circuit or short circuit, which may lead to a circuit becoming unstable, all unstable circuits, they start oscillating. So I cannot use the conventional Z, Y, H, ABCD for my high frequency analysis. I'll go for a different set of two-port parameters, which are going to be called as S parameters. And S stands for scattering parameters. And all these S parameters are derived from the basic Z, Y, and other parameters only. So just like that, S parameters did not come. So S parameters are derived from their basic low frequency parameters only.